Should we start now?
Yes, sir.
Okay.
I can start.
Okay, we'll start now. Okay, for second session. Okay, let's go.
All right. Thanks, everyone. I hope you had a good break, and I hope you did some stretching. As I have the stretching image here. In this part of the session, I'm going to be covering about an interesting topic. It's a fun topic, so you can ask me as many questions as you want because I know everybody across the globe right now is curious about NFTs. So I'll be doing a brief introduction to NFTs for maybe about 30 minutes, and then 15 minutes, 10-15 minutes, I'll talk about Covalent. And we'll have some time in general to see the different NFT marketplaces that exist out there. What are they doing? And what are the different spaces for innovation in this NFT marketplace? We have some time. Maybe we could do like a developer 101 for near uh, before we start with the hands-on session. So, all right. Um, is anybody aware of this image? Are you familiar with this image? Have you heard of this image? Have you seen this recently in the news? This has become one of the most popular images in the past couple of months. Also, one of the most expensive images. This image is a collage image by an artist called Beeple, and the image is titled "The First 5,000 Days." So, this artist, every day, this artist created some small piece of art, and this artist has put the first 5,000 days pieces together as a collage. And this image quite recently sold for these many INR. It's basically it's 506 crores of worth of money somebody paid to buy this image, right? Uh, you may think why. You may have so many questions, I'm sure, even on this number that I put here itself. But this is what I would say is one of the interesting things about technology, right? When you have something unique that you can possess, you would pay like millions and billions of dollars to get that, right? Now, what are these unique images? Like, what is so unique about it, and how can we ensure that this image itself is unique, right? How can we ensure that the details associated with this image is unique? How can we verify all that? So this is where your blockchain kind of comes into picture. Before we go into, so this image was sold as an NFT. This is an online digital. This is a digital art, not a physical piece of art, right? And this has been, from my knowledge, one of the most expensive NFTs that have been sold in recent times. So before we talk about NFTs, let us understand a little bit about assets. This is not just in the context of NFTs, but also in general, it is important to know what is asset digitization. So you have a context to actually, this is a bit of like a reverse thing that I'm doing, but it's important to understand what are assets before we move into the whole NFT ecosystem, right? So NFTs, it's non-fungible tokens, right? This is the full form of that, and we will come to what it means a little later. Let's talk a little bit about assets 101, right? So what is an asset? An asset is something that is useful or valuable. It could be a mobile phone, it could be a mug, this could be like, this could be super valuable to me. It could be an object, it could be an expertise, it could be a cryptocurrency. Um, what do you do with these assets, right? You trade, exchange, buy, sell. You can do anything with these assets in a marketplace. For example, like Today I have I know something about blockchain. I have been in this space for a bit of time. That is an asset. It's one of my assets, right? Um, I hold some cryptocurrency. That's a different type of asset, but it's an asset nevertheless. It is something useful. It is valuable to me, right? What is digitization of this asset, right? Creating a digital version of these assets, right? Whichever asset it is possible to create this digital version of, that process is called asset digitization. A simple example would be creating a digital version of physical analog assets, for example, documents, tradable goods in the supply chain. You can even create a digital version of this specific asset that I own, right? My mobile phone. How do you create a digital version of this? You have a unique number that is there in each of the devices, and that unique number can be used to identify this particular device, right? So that this the whole process of asset digitization is where the world is going to. It's not just physical assets anymore. All of the assets, we want to create a digital imprint of that asset. Let us see what happens in the process of asset digitization. The rights to an asset are converted into a digital token on blockchain. So for the physical assets, you are creating a digital footprint, right? The rights to an asset, that means I own this particular asset, right? At the moment, and somebody has verified this. It's how they have seen the Flipkart reports, or how do I associate a verification with this? I add a receipt that I purchased this from Flipkart like 2 years ago, and this has like my related contacts or something, right? Some sort of proof. So all of these details can be logged onto the blockchain, and this asset itself can be converted into a digital token if required. Right? Um, Ownership rights are transmitted and traded on a digital platform. So what does asset digitization do? Once it is recorded that a particular asset belongs to a particular person, this person is the owner of this particular asset. All of these details that are captured on the blockchain, now it becomes easier to transfer the asset, right? I can directly transfer the ownership of this asset to someone, right? And I can trade this asset on a digital platform very easily once there is a digital footprint. Now, what is happening as of now is real world assets can be represented on the blockchain using digital tokens. So most of these assets so far were fungible tokens, that is your cryptocurrencies, that is assets, value assets were being represented as tokens on the blockchain, right? So what is the cycle? Your physical assets get a digital footprint. Now the ownership rights can be transferred digitally, right? When I transfer some amount of cryptocurrency from one account to another, that means I'm transferring the ownership of that amount of cryptocurrency from this account to another. Similarly, any other digital asset recorded on the blockchain, its ownership can be transferred from one account to another. Real world assets can be represented in the form of digital tokens wherever that kind of use case arises. So, what is asset tokenization, right? We have been telling that real world assets can be represented as tokens on the blockchain. How do you do it? What is the process? Tokenization is the process where we convert the ownership rights in an asset into a digital token. So, for example, if we have an asset that is worth $200,000, it can be converted into 200,000 tokens, right? Each of the tokens having some name. Obviously, all of the names are the same, where each token is equal to 0.0005% share of that asset, right? Because your asset itself, right, is valued It can be just, even though its value might be $100, you may just represent it as one asset. You need not represent it as 100 tokens, right? So this is just one of the use cases. So you can follow this model for asset tokenization, right? So if you're thinking about tokenizing a particular asset, you can think of it this way. But there are some assets for which you cannot have that many number of tokens, so you can represent it as one token as well. It's completely your choice. Now where the sharing part comes into picture is, can this asset be partially owned, right? That's one of the questions you may want to ask. And if yes, then you can create x number of tokens, or then you can represent that as x number of digital tokens, right? So once you have created the digital tokens, the tokens are issued on any blockchain platform, like you create the tokens on any platform that you're interested in using smart contracts. For example, a near blockchain, right? You have created the token for your asset. So I have an asset and I've created a token, say house, it's a house asset. Um, when a user buys one token, right, that you have created, it means they buy 0.0005% of the asset's ownership. If someone buys 80,000 tokens, they own 40% of the asset. And if they buy all the 200,000 tokens, they become 100% owners of that particular asset or property. This way, asset tokenization allows you to own partial percentage or a fraction of the asset. Thereby, the returns on the entire asset, that fraction you will get as a return for yourself. This has created a lot of buzz in the industry, or this has created a lot of thinking in terms of a global world, right? If there is a house that is there, say like in a resort in Maldives, is priced at X amount, and there are certain number of tokens that it has been certain number of tokens that that particular asset, a certain number of tokens created to represent that asset. If you have some amount of money, you can actually invest in part of that resort, and the whole return, the end. So when whatever returns, whatever profit that resort makes, that percentage which you have invested, you will get that much percentage from the return. So this is one of the real estate concepts that is going very wild. A lot of people are trying to build solutions on this, but of course there are a lot of legal implications associated with owning something which is not in your own country, like buying land, etc. But it's a possibility, right? So this is where your asset tokenization, tokenizing a physical asset, comes into picture. And this is not just for physical assets, this is also for digital assets. You can create digital assets and represent them as tokens on chain. So, how do we digitize assets? This is not important. Why tokenization? Because tokenization gives you increased liquidity. You're able to sell, if you own part of the uh, resort, for example, you're able to sell that very quickly on chain, right? Whereas actually having to deal with documentation that might take like thousands of years. Reduce costs in terms of your transaction cost, right? Because when you are buying or selling something, it can become very expensive, the whole process, depending on the asset that you might be buying or selling. And if it's on chain, then it's just a transaction, right? So there is reduced cost. Faster settlement, of course, because it's all on chain. You sell, you buy, everything is instant settlement. So how does blockchain support tokenization, right? Um, it provides an immutable record of that asset, of that particular token. For public blockchains, it's a public distributed ledger. So you can see who transacted how, when, which part was owned by who sold it, who bought it, all of this. Um, it removes territorial barriers. You can send money to somebody who's miles away, who's in US, Europe, Australia, and whatnot, right? And it allows for something called fractional ownership. You can own part of those assets, even if you don't, and it could be a good investment for you, right? You may not be super rich, but you could invest in part of certain assets that could bring you good results, quick and cheaper transactions, right? It's just a click of a button. You click, you sign, a transaction is done. And on blockchains like Near, the transactions are very, very cheap as well. So now we come to the important concept, that is difference between. So we have seen what are assets, what is asset tokenization. Now when we come to tokens, that's what it means, right? Creating tokens representing your assets. Now we have two different types of assets. One is a fungible asset and another is a non-fungible asset. Let's see a very, very primitive difference between these two, right? Fungible assets are assets that can be swapped with an asset of the same type. That is, they're interchangeable. Now, 50 rupees can be swapped with 5 10 rupee notes, right? So these are interchangeable. Now, similarly, $100 can be swapped for, I would say, what, 7,500 something rupees, maybe 7,400. So again, fiat currency is a fungible asset. That is, it can be swapped with each other. Right? Whereas there are certain assets which are very unique because their creator has created them in such a way, right? For example, think of two houses where they are making khichdi, right? So you have house A where there is cook A who makes khichdi, house B where there is cook B who makes khichdi. Even if they follow the same recipe to the T, which they may not, the assets are labeled as khichdi, but they are not interchangeable. They are not the same, right? Why? Because each of these assets are getting their unique characteristics from their creator. The way the creator defines how the khichdi should be made. They may make a khichdi with yellow dal. They may make a khichdi with green dal. They may make a khichdi with moong dal. They may choose to use basmati rice. They may choose to use plain rice. The creator thinks of how the final outcome should be of that particular asset. The creator creates the assets. So the asset is unique in itself, right? Even if a similar asset is created somewhere else, it might be completely different than what this asset is. That asset is unique in itself because that creator has thought of creating that asset in a particular way, right? These kind of assets are called non-fungible assets. They cannot be interchanged with each other, right? So these can be translated into the token world as fungible tokens, tokens that can be interchanged. For example, if you're on Ethereum blockchain, right? Um, you can exchange Tether USDT, USDT to Ether, right? Today you can see Ether is 1,700 or 800 odd dollars, $1,800. It can be exchanged with dollars, right? So these are all fungible tokens. You can pay some money, you can buy the tokens, right? And you can pay the sell the tokens and get the money. Right? So these are fungible tokens. Whereas non-fungible tokens, that is your NFTs, are assets that cannot be interchanged with each other. These are like your unique paintings, right? You pay some money, you buy the painting, right? Now you can't just exchange that painting for that money directly. You know, you maybe somebody likes that painting, they may buy it from you for at a price, but it's not exchangeable for that price. You know, Similarly, you buy two paintings that probably cost the same, right? That doesn't mean you can exchange one for the other, because it's about your preference. What kind of paintings do you like? It's about the creator who created that painting. Maybe it's about the colors of the painting. Maybe it's about the design of the painting. There could be so many different things that could appeal to you, right? And that's why you bought this painting. Somebody else bought some other painting, even though if it's for the same price, but for some other factors, right? So these assets are non-fungible assets and are represented as non-fungible tokens on the blockchain. Now, what are non-fungible tokens, right? And what are some things associated with these non-fungible tokens? Non-fungible tokens, they can represent a digital asset that is unique in nature, right? That is, you have, for example, a painting, right? You can think of a digital version of a painting, something somebody has created very uniquely, right? And that is a digital asset that can be represented as as an NFT on the blockchain. What do you mean by representing that digital painting as an NFT, right? What happens is, uh, you record the ownership of that particular NFT. You can record things like who owns that NFT, who owns that image, who created that image, and other details about that image. What is the name of the image? What is the description? On which date was it created? Right? All of this can be recorded as data on the blockchain using smart contracts. The ownership of the NFT can also be easily transferred and traded online using the secure blockchain smart contracts at the backend. Why are NFTs becoming popular? Because it is a very secure way of creating digital ownership of things that are scarce and unique. Paintings that are paintings, drawings, objects, domain names, which are completely unique in nature, right? So you can securely create an ownership space for them. Like, I created this painting. I can mint this on the blockchain as an NFT, and I can transfer it, sell it, etc. Right? So that's why NFTs are becoming more and more popular. There are some popular NFT standards, ERC 721. What are standards? Standards are nothing but rules that are associated to that particular token. How should that token behave? What are the different functions that are associated with those tokens? Those are your standards, or also known as rules. Popular NFT standards in the Ethereum space are ERC 721, ERC 1155. Then in Near, there are two popular NFT standards. One is NEP4 and another is NEP 171, which is the latest NFT standard. And yeah, so each of these standards describe how that particular NFT should behave. How does that behave on the blockchain itself? Right. Like I mentioned, NEP4 is one of the interesting NFT standards by Near. Actually, NEP 171 is the recent one. I'll see if I can show you some documentation on that as well. But NEP4, so NEPs are near enhancement proposals. NEP4 describes the NFT standard. Let's see if I can show. Yeah, okay. It come. NEP4. So NEP4 is a reference implementation that is for NFTs. It is a very simple standard which is describes some bare minimum rules to support ownership and the transfer of NFTs. Um, it includes the possibility of delegating authority to other users or other smart contracts. So you can you can let somebody else do the transfer on your behalf. You can let somebody else sell the NFT on your behalf, given all the right approval calls have been made, right? So what this means is that when we add some future enhancements, it can be just added with cross contract calls. Instead of upgrading the entire the contract that we have right now, we can make some cross contract calls and add the enhancements. So let's take a look at the NEP4. Standard interface for non-fungible tokens, allowing for ownership and transfer. So as you can see, we can have multiple types of NFTs, digital goods, collectible items, unique online assets, etc. So the core use case for NFTs is speculating on value. How much is this particular product worth, this particular digital asset worth, and trading them, trading the unique items amongst different buyers, sellers, etc. So we don't need this guide level. Yeah, this is the reference template that I want to show. Don't worry about the code as of now, but basically you can just see what the reference template looks like. That means what and all describes an NFT standard. Like, the caller of the function should have access to the token. So grant access is this function. So if you call this function, whoever is calling the caller will have access to the token. Then revoke access. This is for revoking access to a particular token. Transfer from one user to another. Then transfer that particular NFT to someone. Check access, check if somebody actually owns that particular NFT or not. Get the token owner of that particular NFT. Right. So like this, you can see there will be a reference level explanation, that is a template for different types of NFT, different types of standards, right? ERC 721 has its own template. ERC 1155 has its own template. NEP 171 has its own template. So you can see what are the different features that this particular standard is allowing for those particular NFTs. I think there might be an NEP4 as well. Sorry, NEP 171. See specs. Okay. It'll take a long time to search, so I'll show you. Probably I'll pull it out during the break. Okay. So how do the NFTs work, right? What happens with the NFTs? How do people sell the NFTs? How do people buy the NFTs, right? The first thing that you need to do is have an NFT contract. So you saw the template, right? That can be converted into an assembly script contract. So the creator or the owner of that particular NFT needs to deploy an NFT standard contract on the blockchain of their choice. So each chain will have their own standard, and they should provide a name and symbol for their NFT. So this is the first ever time you are actually creating an NFT, right? Out of your digital art or out of whatever digital asset that you want. The next step, and this is what you might have heard popularly as minting, the process of minting. So there is a function called mint, right, which helps you create the tokens. So this is the next step. Once you have the NFT contract, inside the NFT contract, there'll be a mint function. Now you will be calling that mint function with the details of the art or the collectible that you would be minting. Once you have minted that, now to whichever address you have minted that NFT, that address would own that NFT, and that address has the ability to sell the NFT using the smart contract. So once the art or collectibles have been minted, they can be put up for sale. Right. Before we go into this, let's see some popular NFT marketplaces. Let us see. Mint base. Mint base NFT factory. Let us see this. Okay. So let us take a look at some marketplaces to see what kind of things are being sold as NFTs. What are NFTs? What is happening with them? Here there are different types of NFTs in this particular. This is one of the popular marketplaces, OpenSea.io. It is built on Ethereum. I'm going to be showing you some from on the which are built on Near as well. This marketplace you can see has different types of NFTs. There's art, there's music, there's domain names, there's virtual worlds that people are selling in the form of NFTs. There's trading cards, collectibles. These are game collectibles, sports, etc. Right? So let me just go to all NFTs. You can see that I can filter the NFTs based on which are buy now, which are on auction, which are new NFTs. Maybe they have some offers, just like any digital products that we sell, right? Now, you can see some different type of art that is being sold as NFTs, right? Um, this is like super, it's a collection from the Bronze series of uh, don't know, some Yak originals. This probably means something to someone. Um, it's oh yeah, we can see the description. So this is the most radiant festival in Brazil, Samba, is an experiment around the impossible and non-existing movements of flag bearer and master of ceremonies recreated by artificial intelligence. The artist who created this has written, even as an artist and creator, I sometimes feel like a spectator of AI creations, surprised and delighted with rare and strange images, colors, and movements created from numbers. So this entire thing has been created using AI, right? You can see some deep A, deep C, I assume probably these are some of the algorithms they have used to produce this image. So this is a type of unique creation, right? Um, this is unique because it has been created, of course, using AI. It represents something, right? This samba, it's a concept. Maybe Brazilians would obviously be able to associate with this more. But these are the kind of things that we can think of as selling as NFTs, right? Even domain names, in fact, we can sell them as NFTs, right? We can say, for example, let's go to ENS names. These are some of the most popular ones. Recently listed, right? So you can see that each of these solver.eth, uh, litaf.eth, or cryptoskins.eth, rolexwatch.eth, ashlar.eth. So these are all unique, right? Adele.eth. These are all unique names. This is a unique asset. The domain name, that asset, has been minted as a non-fungible token and is now being sold. So if you click on this, you will get the details of this particular token, like what is the description, what is please check the expiration date to keep your name. So other details, like to keep this particular domain. Each domain will have some expiration, right? We keep paying yearly for the domain sometimes, or monthly, whatever. So this also has some details associated with that. What are the properties? It's a short name. What are the stats about Ethereum name service from where the domain has been purchased? What are the details? There's a contract address, a token ID, and which is the blockchain, that is Ethereum. So all of this you can find for an NFT, right? The ownership of this NFT, the transfer, sale of this NFT is very straightforward. Similarly, you can see a couple of this is Mintbase, which is a marketplace on Near. This also has different types of NFTs. This also facilitates a concept called store. So there can be like a store which is having a particular collection of NFTs. So you can see that the transaction fee is like very, very minimal. So you can mint it for cheap, you can buy it for cheap, etc. So you can see all these like really nice, beautiful things as NFTs, digital art that has been created. So this is Mint one of the NFT marketplaces created on Near. It also allows you to be on testnet. You can create a store using testnet. So I'll let you all explore this. I'll send you the link whenever you have some time. So the process is like very easy. You just need to log in. I probably have it. It seems like I already have an account. So I just want to show you how to mint an NFT. That is the purpose of this. See, I'm on testnet. Okay. I need to connect my testnet wallet. I already have a testnet account. I'll send you how to create this testnet account as well. So you can create your testnet account here. We will be creating this using JavaScript in our hands-on session. So I can now deploy a store, right? So I can just create a store name like Gyan Art or something. Okay. G. So to deploy a store, I need to pay 7 Near. But of course, I have a lot of dummy Near in my testnet, so that's not a problem. So in a store, I can create a bunch of NFTs, like I can have a collection of NFTs. All right, so the store is deployed. Okay, so here you can see time to mint. Mint. Okay, so now we are actually minting an NFT. So what I'm going to do is I'm going to take some dummy image or Aurora image, right? So here is where the artist would be uploading their digital creation, right? So it is uploading the file. Okay. This is a test. Now there are categories, so I'm going to call this art. I can also add royalties. That is, somebody and I am reselling somebody's art, right? Somebody was the original creator. I can add royalties for them. That the revenue will be split between ABC, right? And I can print multiple digital copies of this. Sorry, mint, not print. So I can have 3, 4, 5, how many ever I want. Sorry, excuse me. I'm just gonna mint one. So every action that I'm doing, you see, when it's asking for some approval from my wallet, it means it's a transaction with the chain. It's an on-chain transaction. What it means is I'm calling a function, right, to do something. In this case, I'm calling a mint function. Earlier, I called a function that was used to deploy the store. So now you can see this particular NFT is minted. Simple. This is how all of these NFTs are getting minted and coming into the market. I haven't set it up for sale, but I can do so. Okay. All right, let's go back. So now that we have learned a little bit about NFTs. We have also seen how we can mint our own NFT. I hope you are able to go to the Mintbase account that I sent, and once you create your own near testnet wallet, you will by default get some money in your testnet wallet. You don't have to worry about that, and you can mint an NFT and see that whole experience, right, for yourself. Now, the other thing that I had mentioned earlier as a part of the agenda is that I would like to cover another interesting topic called covalent. Covalent basically provides a unified API for bringing visibility to a lot of blockchain data. So one of the shortcomings, or one of the things that people realize as they started building applications on blockchain is, now people who are coming to my application, they're using my application. How do I get insights from the application? How do I query data from the chain, right? Every time querying data from your actual chain can be very uh, I wouldn't say expensive, because read is not an expensive operation on blockchain, but it can be very cumbersome, right? And for developers, or for those who are not very familiar with how to query data from the blockchain, it might become really difficult, right? That is where Covalent comes into picture, where we are able to query the data from a particular different types of blockchains very easily using these unified APIs provided by Covalent. I will also show you the other marketplace. Uh, I will show you how it looks. I'll also be able to show you the reference docs. So, okay, while it loads, I'll come back to that. So basically, what is Covalent doing? It is giving us all the access to different types of blockchain data by just giving us some API endpoints using which we can access and get the data. So why covalent? Because blockchain data can be very overwhelming to read on explorers, right? So if you have done transactions on top of blockchain, you know that to see the details of the transaction, you generally use transaction explorers. But the data on the explorers is more or less like a huge data dump. There is a lot of data that is present, and you have to write some web scraping to actually scrape the data from the explorer to get the data, and then you have to clean it, and then you have to use it. Whereas these kind of the covalent APIs directly give you access to the data which you can use in your applications. The second important thing is, of course, as more and more decentralized applications are being deployed on chain, it is becoming important to derive insights on the performance of the applications and the chains themselves. So when we choose one chain over the other, we say scalability. We say that, oh, the transaction fee is like super less. I made like 1,000 function calls, but it didn't charge me anything, right? Now, how do you get all of this data? How do you get how much gas fee you have spent? How do you get the data as to how much has been charged for particular transactions, right? That is where the Covalent API comes into picture, where you can get the data of how your app has been performing, how a particular chain has been performing, and analyze that data. The third is that the APIs help you figure out if you are a trader or even if you hold some cryptocurrencies. These APIs will help aggregate historical balances, calculate the profit and loss across the different protocols in one single dashboard. And when we are specifically dealing with NFTs, there is a lot of metadata associated with the NFTs, as you saw. There could be description, there could be tags associated with NFTs, there could be royalty splits, there could be information about the artist of that particular NFT. So all of these metadata and transactions would need to be analyzed. You would need to get this data from somewhere, right? And that's where these APIs can act as a one single point of contact. So how does Covalent work? if you see, you as a developer, your touch point is at the rightmost. That is the API, the setting, right? So you hit you see different endpoints. I'll show this to you as well in just a minute. You have class A endpoints, B endpoints, and C endpoints. As in, all the different types of endpoints have been categorized into different classes. You can hit either of these endpoints, right? And Covalent will do the job of actually running the nodes and getting the data from the different chains. So you can see that Near is one of the supported chains. You have Ethereum, Polygon, Avalanche, and whatnot, right? Um, so, as a developer, your job, whatever after Covalent, whatever is there, everything is abstracted to you, right? You don't have to worry about going to the transaction explorers, web scraping, getting the data, etc. No, all the data is fetched by Covalent and sent back to you in your API response based on the type of endpoint you hit. So there are different chains that are supported in Covalent, as we already saw. Every day, more and more support is being added for the various chains. You have Near, Binance Smart Chain, Phantom, Polkadot, Ethereum, and whatnot, right? Now let us actually see the APIs in action. There is one app example, which also I will show you. So yeah, here you can see all the different API endpoints, right? So Covalent Blockchain Data API. Let's see. So you can see this is class A. You can see the API called Get Token Balance for Address. So for this, actually API key. I can share this with you if you are interested to get an API key for yourself. You can do so. Just requires no, it's not. So there is a question. If Covalent is similar to Infura, no. Infura provides you the ability to connect to the chain, whereas Covalent is more focused on getting the data from the chain. So I'll show you. So I need my API token. Yeah. So I'm just setting my API key. Now that I have set my API key, I can make some calls and get some data. So here it is like get token balances for addresses. So if you see, as you can see, all right. So you can see I'm on Ethereum mainnet and I have about some 400 USD, some ETH. So here in this API, it asks me for a chain ID and an address, and it'll give me all the balances. So I'm going to give this particular address that I copied from there. For Ethereum mainnet, the chain ID is 1. So you can see that I have ETH, I have 1967632, whatever that point. Could see this 1976 ETH. So you can see that here as well. I had some dye, seems like earlier. So this is giving me all the balance of my particular uh, wallet. Similarly, I can get a historical portfolio of my wallet over the time. I can get the different transactions. I can get the ERC20 token transfers between one wallet to another. I can get the block details. I can get the block heights, log events, NFT related data like metadata, IDs, transactions, etc. So you can see these are class A endpoints. Then there are class B endpoints, which are specific to certain swaps. So there's Sushi Swap, there's Aave. These are all DeFi applications from where we can get data. Then there is class B, which are pricing endpoints. So we can get the historical pricing by a particular contract address. We can get spot prices. We can get this price volatility, etc. Right? So this is like something cool that helps you get the data and view the data from the blockchain, from the various blockchain. Right? So this is an example of an application that we actually built over the weekend. So you can see, right? These are all data on the testnet that we generated ourselves. So you can see the wallet balances. You can see the different transactions that are happened for one particular wallet address. So the address we have keyed in by default. We can change the address and update it here, but you can see like what are the number of transactions, what are the value, how much was value transfer transactions, how many contracts were created, how many contracts were how many times contract interaction calls took place, what was the average gas spent, what is the total value of transfers in that native token in USD. What is the contract with which they interacted most with the users, probably, right? And you can see the transactions here, value transfer, smart contract creation, smart contract interaction, etc. This is an interesting one. We created some dummy NFTs just to show, and we added some music. So here, of course, this NFT images are getting cached, but you can see that once we click on them, we can hear some music as well. Have to keep refreshing this for the images to come. But basically, you can build something like this using the covalent APIs and the blockchain itself, right? Like you can build a wallet which can show the different NFTs that are there in your wallet. You can add some features to that, etc. You can see the spot prices of the different things. So this entire thing we built using the covalent APIs from the data that came from the blockchain, and the blockchain that we use is Phantom blockchain. So you can use these kind of data APIs for working with your application, which will make it very easy for you. So this is what I had. I have a developer primer. So since I have time, okay. So these are a couple of set of slides that is a little bit more geared towards hands-on. So this is basically workshop slides for web developers, which we will be doing most of it in the second half. But I'm going to just show you a little bit of how things work. I've already given some of the prerequisites, that is to install Node.js, install the Near CLI, and create a testnet account. I think this was not in the prerequisites. But if you do have time during the break, I would request you to do all of this, right? So if you are coming from Web 2 to Web 3 as a developer, right? In this case, what would you see? What would you experience? The different things, right? So the topology in a Web 2 application is like you have a client server application. You have a client that is making some requests, then you write some server code at the back end, you expose some APIs, you send the data back and forth, right? In Web 3, there is a server plus your blockchain, right? So sometimes your client or your front end would directly interact with the blockchain itself. And if sometimes you may need a server where you want to store some data like API keys and whatnot, right? So that's a small difference. That is, you would not just be interacting with the server, but you would be interacting with the blockchain itself, right? From an app dev perspective, you may have a JS front end, or you may have HTML, CSS, JavaScript, or you may use a React.js, you may use an AngularJS, and any other backend tech that you might be interested in. The front end would again in the Web3 ecosystem remain the same. And then you would, for near specific, you would use like a Rust or assembly script smart contract that you would write on near. From a security perspective, you use a username or password, and then you add some OAuth to that. Sometimes some kind of in the OAuth, you may have some JWT tokens that are being passed back and front during the session, right? Whereas in a Web3 world, your accounts are nothing but your wallets. So you use your wallets to connect, and that is the one that is used to authenticate. That is the one that is used to authorize you to perform certain actions, as you just saw me doing, right? When I was minting something, it asked me to authorize that particular transaction, that particular smart contract call. And each of the accounts are have a public and private key pair associated with them, which is what is used for signing or representing that particular. From a server's perspective, we use AWS, GCP, or Azure servers to deploy our contract, right? In the Web3 world, apart from what we use the servers to deploy, there is an underlying mechanism to the network itself, to the chain itself, right? Which is a consensus protocol, how the chain functions. It could be proof of work or proof of stake, etc. Whatever a couple of things we have already seen. The key performance metrics is that it should be fast, it should be cheap, and it should be that the data is native. Whereas in a Web3 world, the key performance metrics are that it is permanent, money is native. It's not data, it's money, right? Your token transfers, your value transfers, those are native to the chain. And it should be unassailable, right? It should not be, you should not be able to break the application easily. Of course, that is the case when it comes to from a security perspective to Web2 applications as well. But what do you see most from a user perspective, from a consumer perspective? That it should be fast, it should be cheap, right? And data should belong to that particular ecosystem. So we won't do this. I mean, not now. Okay. So there are two paths to building a near application. One is contract development, right, which we will be doing in the second half. And other is the UX development. We will not be doing the UX development in this workshop, right, because it requires us to have some more components. We'll focus on the contract, which is the backend part, most important. UX is common for Web2 applications as well. So we will be using the near SDK AS, which is one of the prerequisites to build the contracts using assembly script. And we can, if you are interested to write the contracts in Rust, you can use the near SDK RS, the Rust SDK. I don't have expertise. I don't have much expertise in Rust, so I prefer to do the assembly script hands-on today. But it's your choice. You can go for either. And then we can compose the deployed contracts using cross-contract calls. When it comes to the UX development, now what you have done is you have already written the contract, that is your main logic, and you have deployed it on chain. So from the UX perspective, you will be using the JavaScript APIs to connect to near, manage the accounts, and call the contract methods. Now, from this UX development, actually, we are doing small parts of it, but it's only connecting to near the node, then creating accounts, creating some small transactions, etc. Right? We'll not be building the end-to-end UI actually. Another way to do is we can use the JSON RPC APIs to communicate with the near from any other context, that is apart from the JavaScript or the TypeScript. And we can manage the DevOps with the near shell. All right. Near protocol for developers, just a brief architectural introduction here. You can see here that the dApp that you build, you will of course be using the Near API JS library to interact with the layer, the blockchain layer. We will be doing this. We will be creating some accounts. We will be connecting to the node. We will be sending some transactions to this. Okay, that is one part. Now another part is your smart contracts that is associated with your dApp, right? Where your actual business logic is going to lie. So for the smart contracts, you can write the smart contracts in the assembly script or in Rust. And these smart contracts are directly deployed on your runtime layer. Right? Once the code is deployed on your runtime layer, that is then interacts with the virtual machine, right? Which has its own read and write, which performs the read and write using its own state storage. And from the blockchain layer, if anything is requested, it would be requesting from the virtual machine and giving it to you using your interaction from the RPC interface. So we would be doing a bit of both. We would be interacting with the node. We'll be getting the details of the node. We'll be creating an account, and we'll be deploying a transaction. We'll be querying the blockchain as well. Yes, that also is there as a part of the hands-on. And for the contracts, we'll be using assembly script to walk through a contract as well as write our own contract. Depending on the amount of time that we have, we'll try to do both. If not, at least we'll do the walkthrough and maybe do a little bit of writing. So you can see the life cycle of the transaction. First, you have the Near API JS. You send some calls to the blockchain layer using the RPC interface. Then that is applied to the virtual machine, and then it gets data from the smart contracts that you have already deployed, and you read the data from the storage. You send the result back to the blockchain layer, which then sends it back to the API front. Excuse me, sorry. Yeah, structure of the sample application. Sorry, this we've already gone through. Okay, so this we will keep for the second. All right. Yes, even for the testnet, it will show the transactions. That is one question, if I'm right. There is one question of what type of applications can be developed. You can develop any type of application on top of blockchain. Any application that you think of building in Web 2 can be built in Web 3, given you have enough use case to add the blockchain layer to that application. So now you know what blockchain is used for. Now you know what kind of features it offers. Now you know where do you need blockchain? Why do you need blockchain? Once you're able to answer the why, the what is just unlimited. Like sky is the limit. You can build whatever you want in this piece of blockchain. There is no limitation of what type of applications can be. Okay, yeah. So we I
Okay.
had this much for the first half. I will be sharing some prerequisites. Again, I will put it all over chat as well. Please ensure that for the second half, you are able to come with those prerequisites. We will be building, let me, I will share one link, Figment Learn. Please create an account on this. So in Figment Learn, you need to go to this pathways and then near pathway, okay, and then setting up an account on data. So you just need your email and your name, right? And you can register and create an account. So we will be walking through this, one of the basic pathways of Near as a part of the hands-on. I have a pre-recorded video that I shot yesterday, so I will be playing that. And then for the other prerequisites that I've already sent, you need to have installed the Near CLI. Let me do that. No worries. Developers. So yeah, to write the smart contracts yourself, you need to have a near wallet. I have already sent the testnet wallet address. So please create a testnet account. We will be doing the same. Actually, it's optional to create a testnet account because we'll be doing that as a first part of the hands-on. Then near CLI, so you need to install this, which is a command line interface tool to interact with accounts and smart contracts. Near API JS, this we'll be installing as a part of our first workshop as well. And the near SDK AS, because we'll be using the assembly script to write the smart contracts. So before the hands-on workshop, if you're able to install all of these prerequisites, then you can code along with me. So it would be much easier. Yeah, all right. That's pretty much it for the first. Are there any questions?
Yeah, thank you, Lakshmi, for such a interesting topics of the tokenization. I have one last doubt, It's normal thing. So we have one house. So if you convert that into token, and the token you are selling through blockchain. So how blockchain is a decentralized approach? So how it will be enforced? Something goes wrong, suppose.
So, sir, basically, what has to happen is, so this is the example that I gave was more like a sample thing. But what would have to happen is all the legal tenders that are associated with the house, it would have to go onto the blockchain. For example, um, this is more of like an ideal world situation where you have some unique ID associated with each of the documents with your house, right? All of those unique IDs can be only accessed digitally. That has to be the rule. Like it can't be like you can also do a physical thing, you can also do a digital thing. No. If you're putting something on the blockchain, it has to be solely accessed only digitally. So all of the unique IDs associate all the documents that are associated with that piece of land or with that house. All those unique IDs would be going into the smart contract as the metadata. For example, just now we minted an NFT, right? We gave some description to that NFT. We gave some tags and all. But there, along with that, we would be giving some unique IDs associated with that land papers or house papers. All of these unique IDs would go on the blockchain. Now, anybody who wants to buy that piece of land or buy that house can only do so through this digital application. So once they are trying to buy or sell or whatever process is associated with that particular house or land, they come to like your web application, some kind of application. They see that okay, here these are the details of this house, it is located in this place, it is these many square feet, and it is priced at this much. So then you can facilitate that when you buy that, the ownership will transfer from this person to this person on the blockchain from account A to account B, and all those unique values that were earlier present with account A will go to account B. Similarly, if you want to distribute, like you want to make a fractional ownership, which is the latest concept that is coming in, that ownership of that will be split to different people with some associated metadata, and all those unique values that are there in the land paper or whatever that are keyed in digital, now made digital, will go to each of the owning entities with conditions associated that they can only sell that percentage of the piece of the house that they own. So
is this okay?
yeah.
No, it's okay. Let's say theoretically it is okay. So now suppose some problem comes, whether there will be some trusted party in this system.
No, sir, there won't be any trusted third party because the trust that's the whole, like, we eliminate the whole trusted third party. Instead, the trusted party or a verification might come before putting the data on the chain. So somebody would need to verify that you actually own that piece of house, right? Who would verify that? There you may use some trusted third party, but once that verification is done, then once the data is on chain, then you don't need any verification. In fact, you should not have any verification once the data is on chain. But before it goes on chain, you can have a mechanism where, to reflect that somebody has already verified my data, you can have a verification process before that, which could be a manual process or whatever.
Suppose tomorrow that person denies that I have not sold this land, then what will happen?
So that's why you have so first of all, once the data of that person goes on chain, right, that has to be like a single source of truth. I have put this data for sale. I have set up this house for sale. When you set up something for sale, that itself is a transaction. So that transaction will be available. You can easily track that. And once somebody buys that, that also is a transaction because it's a transfer from one person to another. So that also you can see that. So all the chain, all the proof you will get on chain, that who set it up for sale, who bought that land, or all of these are in the form of transaction IDs, which we can show as proof that they can't deny that I didn't set it up for sale, but it came from your account. So how can you deny? Right? The transaction, see, here is the transaction. So we can show the transaction as proof.
Yeah. Okay, so some kind of miners will be some kind of officials.
No, you from your account you can directly make a call. It's something like set it up for sale, like that. So when you're setting up something for sale, you make some kind of announcements, right? In today's world, if we are selling some small object for sale, we put it up on OLX or something. Then somebody calls their phone number and verifies whether it's actually there for sale or not. So over here, all the verification process is gone because the set for sale is a command that is going to the contract, and that is coming from a particular account, and a person who owns the account is signing that transaction, saying that yes, I'm performing this operation. That acts as a proof of action, if you could call it that. So you can say that this sign came from your account, and this command for sell this came from your account. So you are the owner, you are responsible. Like that, we can give the ownership.
Yes, so some kind of double spending may be there. So the one way he can sell to this way, like tokenizing and then blockchain. Maybe let's say it takes some process, maybe 1 month or let's say 1 week. In between, he may sell the same land through other way physically.
Yeah, so that's why I'm saying that if we are digitizing this process of selling, we should completely cut down the physical. Both of them can't coexist.
Okay.
Yeah, like I can't sell this on blockchain as well as physically, right? Then there is no point. Like it can't coexist. It has to, once it migrates completely digitally, the physical process has to be eliminated.
Yeah, okay. Yeah, thank you. Any other questions? One was asking Amar Rasi.
Yeah.
No questions? Okay, thank you, Lakshmi, for such an interesting topic. And we'll meet again at now it is
1:30.
2:40 we'll meet. 2:40, okay?
Okay, sir.
So all the participants 2:40 will meet.
Yeah, please install the prerequisites, so it will be very helpful to
Yeah, if you
do
need
the
more
hands-on
time,
session.
maybe you can meet at 2:45. If you need,
Yeah, 2:45 is fine if you need more time for prerequisite
yes.
installation.
So,
I
so
was
till
asking a
that
question.
time,
I guess my voice did not get through. Hello.
yeah, you can ask
Yeah.
Amarasi.
Yeah, I was asking a little question, but I guess my voice didn't get through.
Yeah, now
You
it is
can
okay.
please ask now.
Just a small question, ma'am. Suppose there is a cryptocurrency I have, or somebody has, or an NFT, or a piece of land I have. So suppose that person dies. So then the cryptocurrency or NFT and all this goes with him forever. It cannot be nominated to others like in the physical deal.
No, that's why you have something called with every account, right? So your representation on chain is your account. We'll see
Okay.
that in hands-on as well. Your account represents you on the chain, right? So with every account, there are two things. One is a public, so it's a key pair that is created
Yes,
for
yes.
every account.
Public and
You have
private
a
key, yes.
public key, you have a private key. Your
Yes,
public
ma'am.
key is what other people recognize you with. For example, your account could be amar.testnet, right? That is publicly known to everyone. So when you say, hey, Gyan, can you transfer 10 near
Yes,
to
ma'am.
me? I'll be like, okay, sure. So I'll just transfer it to amar.testnet because I know your public account name. And you can see that it has come from gyan.testnet. Okay. Now, if there is some sensitive, now to actually for me to transfer this to you, I need to sign that transaction. That means I need to say that I am authenticating this transaction. It is me only who is transferring this. So I need to sign it.
Yes, ma'am.
To sign this, I
Yes.
need the private key. The private key is your secret key. Now, of course, before you like how we give our passwords to this to our spouse, or we nominate them for something like receiving the money,
Actually, I
etc.
heard that someone died or 7 million cryptos went forever when
Yeah,
he was.
because they did not share their private key with anybody else.
It
So
happens with
they
the
could
land
not
also.
retrieve it.
Smart contract also similar way.
Uh,
No.
no, so your account is your gateway, right? Your smart
Right.
contract is nothing but your business logic, right? So smart contracts are like your business, right? Your company. But who is managing the company? Some account will be there, like your bank account, right? Which is
Okay.
holding the funds of the company, right?
Right.
So smart contract is like running the company. Anybody can come and run the company. That's not a problem. But
Okay.
the funds that are being gated, are being sent, received, etc., are through some kind of account. So that account is the one that represents you. That account has a password, like how your probably your signature, or your nomination or whatever in the bank sense. But in this sense,
Right.
it is your private key. Your private key is the secret key. So if you lose your private key, or if you share it with malicious hackers, gone. Everything is gone. So similarly, if you want to transfer your crypto, or you want to have a backup to somebody else who wants to access your crypto, then you can give them your private key. That's it.
Okay. Okay, ma'am. Thank you, ma'am.
Yeah.
Okay, thank you, Lakshmi. We'll meet around at 2:50. Okay, 2:50 maybe.
Yes, sir.
2:45,
2:45, 2:50. Yeah. Yeah.
Okay.
Yeah.
Okay, thank you, thank you.
Thank you.